Hello, everyone, and welcome to my presentation. The problem I'm solving here is multi-class detection algorithm on different categories of cyberbullying. So this problem has been studied extensively in the literature, and many first side of the problem have been used in binary classification, multi-classification. However, there are some lacks that my work tries to fill out the gap, especially on the way the data was analyzed. So this problem is very important because cyberbullying affects age, gender, ethnicity, religion, and many other kinds of attributes that has not even currently been exhausted. So in this particular presentation, I'll be benchmarking my model and what the current state of the art has proposed in the literature so far. For example, in the data exploration, which is where the main work of this presentation relies, I found out that the current state of the literature tries to reduce the data set and eliminate some features, which I strongly refute that claim based on the fact that I acknowledge there were duplicates in the data. And if we look carefully on the pipeline that I suggest here, we start by presenting the data set, which has 47,000 or more entries. It looks balanced from the onset, but after cleaning the data, applying pre-processing, like removing all the emojis, the empty words, stop words, and trying to filter out the data, we realized that the data was no longer balanced. Some of the classes have more entries or features than others. However, there are techniques in the literature and in machine learning to handle this problem, which is not really a great issue at this point. So the current state of the art actually eliminates one particular column, which I don't agree with that analysis. And I use the proposed algorithms that so many works have been doing. And even though I did some tweak to increase performance. Now, what embeddings was also a challenging aspect because based on the way the algorithm, each algorithm works, tokenization, which happens not to be a standard. For example, the TF-ID, and the counter vectorization works differently on different models. For example, I will show later on that my models that I use, some of them could not perform well on different kind of algorithm. Also, I discovered that even though it looks like a multi-class problem, it was more to that. It also had multi-labels. And I tried to look into most work and I realized that multi-class classification and multi-label are treated differently. However, it was a challenge to me, so I tried to reduce everything at this point to multi-class. If we see in this slide, you will see the slide on my left. For example, this entry was classified, this entry was classified under gender, and the same entry was classified under other cyberbullying because this is one of the classes. Now, the authors eliminated the other bullying that it was not ambiguous, and if you look into the aggregation of the clean model, they were very defined and had no classification context that suggested them. If we look on the other ones that were not bullying and the other things like gender, they still have multi-labeling. Multi-labeling in this context can come in the sense that I'll take the use case of our class here. We can be students at the University of Toronto. That is a generalization. Inside the context of being a student in the University of Toronto, we might be Blacks that qualify us or indigenous people for this program. So we have two labels in that context as students. Inside that, we can be female, male, non-binary. We have the third label to describe somebody. So somebody can have multiple labels in this context, which is a true problem. So I will not really go by eliminating that column at that point. And after applying the cleansing, we prepare our text, removing the stopword, as I said earlier. We now ready for tokenization and embeddings. So if we go further, we realize that for the data set that was still unbalanced, but all the 6 classes, I tried to visualize it using a box plot on my left. I realized that above 50 word counts per entry, most of the words were really outliers. So I had to cut the word limit from that limit. So, and I have now a shape, which if you see the distribution to my right, you will see that the blue, which is the not cyberbullying, and the red, which is other cyberbullying, have equivalent distribution. Gender and age have a gender and ethnicity, sorry, have a kind of similar distribution. Religion and age have a kind of similar distribution. That gives me a lot of insight on how to do further proceeding with the embeddings. But before we do that, we need to do class balancing. I use random oversampling technique. So I try to use the minority class and make them equal to some of the classes that were majority. For example, majority class will be like religion and age. And if you see not cyberbullying and other cyberbullying are the minority classes. So when we apply that, we now move to embeddings, try to use text data and give them numerical numbers, which the neural networks or other learning algorithm now can use. On my models, I use logistic regression, the naive Bayes multinomial classifier. I use recurrent neural network, which implements the long and short-term memory. And I also use the transformer, the BERT, which uses the attention mechanism. So based on that, I realized that for my multinomial model, it had a very good accuracy if we based only on accuracy as a measure for performance here, as compared to the one versus the rest logistic regression. So the one versus the rest takes one class and the rest and compares one against the rest, goes to the next class, takes that class compared to the rest, and in the end it aggregates to see which the best predictor for that class. So the multinomial model here had 83.0%. If we look on the other hand, I try to expand the performance metric to use precision recall F1 measure, because the F1 measure gives a kind of balance. So I think in this analysis, I would really prefer to use the F1 score to be a better indicator for my model. Keep in mind that the text classification or my data processing might not be at optimal the way it could really be, because I still see room for improvement, but the limited resources, I could not handle it at this moment. So if we see 75% at this point, it was actually when we have done a lot of cleansing and using all the classes that were available. Now, if you see the confusion matrix to the right for this same life-based model, we could see which of the classes, for example, to the true value on the left, when it was true value like religion, how often did it predicted as religion, and the misclassification like not bullying, it wrongly predicted at 237 times. If we go across the predictors, we see that the class that prior works reduces was not even a threat. More other classes even predicted worse than this class. So I don't really see the reason why the authors eliminated this class, and their reasons were not convincing that much, even though I appreciated what they did. Also, for the bidirectional long and short-term memory, we had 82% accuracy, which is a little bit less than the logistic regression and the naive Bayes, which was the base model for here. This is also explained because my model could not run multiple times on the, like a lot of epoch. I only had to do one for the lack of resources. Anytime I try to go a couple of times, I will always have freezes and Google collapse crash. So this is the result of one epoch, which is not representative at all to present a result. I need to do at least 5 or 10 models based on what the pipeline suggested. But the model had to reduce the parameters just to have some figures. So if we look in all the results that I walked through from the different 5 models that I ran the data set on, even though the naive Bayes suggests a better model, the breadth and the long and short-term memory had better opportunities to do better. I did not give them just equal treatment. And this is something that for my future work, I would really like to use more resources, either on a dedicated computer or increase some resources on the Google Colab, so I could go beyond the available provision to work more. It's an interesting problem on natural language processing, which I have learned a lot. And this project has really exposed me to more resources that I think I will look at pursuing